Right, thank you. Hopefully everybody can see my screen nice and clearly. So in the next 40 minutes or so, I'm going to talk about API design and what makes a good API. So a lot of this is actually about ideas and concepts rather than specific Oracle technology, but we'll relate it back to some of the Oracle tools that will help us along the way. A lot of this is, will work for many different contexts. So let's move on. Very quick introduction to me. I'm a father, blogger, author. I work here in the UK, so I apologise for my English colloquialisms and slang if it comes up. I work for Capgemini in the UK as part of the UK Oracle team that have picked up quite a few awards over the last few years. And I have a website called MP3 Monster, and everything you all need will be found there. So I run a developer meetup in London. There's some of the books and articles I've contributed, and these are the big ones. One is Fluentd, which is a CNCF initiative, and a couple on Oracle technologies. This page is all you will ever need to take in terms of notes, so don't worry if slides go through quicker than you can jot in your notes down. All of this information and much more is on my website. So feel free to go and revisit the content if you like, or try and contact me through the site or my social contacts if you've got questions, and I'll try and help you as best I can. As I say, I work for Capgemini, which is a global organization. I won't say too much more about that, other than to say here in the UK, we're still growing and recruiting. So if you're in our part of the world or want to be in our part of the world, then there's opportunities. So when I started this journey, it was very much from a perspective of trying to help a number of customers develop their APIs. And what I was finding was there were some interesting conversations, common themes kept coming back. So I thought, let's go a step back and identify what is an API, what should it be able to do? Because we often overload and put lots of different meaning into an API and assume quite a few things. So I went to Wikipedia as the kind of universal source for simple definitions like APIs. And this is what Wikipedia has to say on the subject. So it talks about communication protocols. Now, most people, if you say API, you will think about REST and SOAP, or maybe if you're a little bit older, WSDL and core-based protocols. But actually, it doesn't matter. It can be almost anything. It's about the fact about communication. It could be just as easily an API can be over JMS or Kafka or gRPC, or even if you're going back in time, shared database tables, or even common shared flat file definitions. It's about the communication. It's not about a specific technology. It's about the tools for building software. So this is about, how can I facilitate creating and defining an API? How do I test against an API? So we should be thinking about the tools to both help the development, help people adopt it, and help people test their work against an API. Communication amongst various components. So that implies that we need to have an agreement, a common language by which we communicate. We're in a social contract here, insofar as I'm talking to you in English, and hopefully you're understanding what I'm saying. And then, of course, it's about making things easier to develop. There's no point in having an API if you can't develop against it. So you've got to think about explaining to the developer the purpose, what the data's for, what happens when something goes wrong. What happens if I ask for something incorrectly, as well as what happens when I ask for the data and I'm successful? So we can pull all that together. So it's technology agnostic. It's about the tools, it's about communication and understanding, so that we're all working to the same message. Now, whilst I've talked about a lot about the other possibilities that could form an API in flat files, database tables, Corba, and lots of other technologies that are out there, the rest of this presentation, I'm going to focus on REST-based APIs. And what you'll see is nearly everything I point out affects all the other different ways you could implement an API. They still hold true. It just is that most of the time these days when we talk about an API, we do mean a REST API, because that's how modern applications want to communicate now. The days of Corba and Corba-based brokers is gone. JMS is giving way to Kafka-based interfaces now, and so on. But it still holds true. The questions and things we should consider can be applied to all of those. So REST was really defined back in 2000 by a guy called Roy Fielding as a PhD paper, which isn't actually too far off when we were getting the formalization of SOAP and WSDL, and the XML standards weren't that old. So it's quite interesting that we initially went down the very rigorous formal route of those kinds of protocols, but now coming back to this more open approach that Roy Fielding put forward. So depending on who you see or hear talking about the paper, that people normally refer to between 4 and 8 key themes, depending on whether they think some of these are worth discussing or not. I've gone for the finer grain thing because there's actually some interesting points, and a couple of them I've regularly encountered as tripping people up. So he talked about a uniform interface and resource-based self-describing messages, which is all about using the HTTP protocols. So you're talking about a URI, and you're talking about entities or resources, and you're using the HTTP verbs to do the operations on them. He talked about manipulating resources through representations. So how do you show an entity, and therefore what verbs do you apply to that entity as a manipulation, like a post or a put, to do update or create style operation. We all know those sort of things, and client server, that's fairly self-evident, and in fact we've almost got to the point where some desktop applications run as a client server in a single environment, so that your application behaves like a local installation, like traditional apps. He talked about stateless, and that's the idea that between each RESTful invocation, we're not dependent on knowing what happened before. We're not dependent on knowing what happens next. So each communication is independent of the others. He talked about code on demand, which is a really interesting idea. I don't think I've ever seen this put to use yet, but one of the ideas is that when you have a web page and you're using REST interfaces on it, you could use the REST interface to actually pass specific code back to run to manipulate your presentation layer and so on, or make new calls to the back-end applications. Layered and cacheable, so these are the two that tend to trip people up, or we tend to forget when we get caught up with the functional thinking of our API design. Layered is the fact that between our client and our server, there can be multiple tiers of technology that are involved in routing it and directing the communication, such as load balancers, firewalls, proxies, and so on. So they're all in there, and we have to be mindful of the fact that they could be affecting the performance and interaction. They have their own configurations, like how long to keep a connection open for, and things like that. And then, of course, some of these devices have the ability to cache, particularly we talk about a front-end browser-based cache, and we've got what's referred to sometimes as a reverse proxy cache. So as a result, the back-end might be able to cache the queries into the database that are used to inform the front-end. So we need to be able to tell the infrastructure in a nice, elegant way in our APIs what data can be cached, what cannot. If your API is reflecting data that's changing very slowly, you can allow caching. But if you're reflecting data that is changing moment by moment, such as trading or exchange rates, you've got to remember that your API needs to express to the back end and all those layers between you and your client what can and can't be cached, or how long the cache is allowed for. If you can handle a couple of seconds of caching, then say so. And then, of course, a good API is self-describing, or as self-describing as possible. When we do APIs and API design, the design process can influence what our APIs look like. So it's worth just having a little think about this. In traditional waterfall, we would start with the design, and then once we've designed the API, we will build it. If you're doing code first, then actually you generate the API documentation definition from your code, which is actually where Swagger started out. Swagger's legacy was a means to build documentation for a product that was being developed at the time, before the value of Swagger and the code generation mechanisms and the other way of doing the notation first really got going. But once you've done the build, you package and you deploy it, and then you might try it out. But you could have a very long feedback before anything in your design is amended to make your API understandable, make it easier to use. Which is fine, but it's not the most effective way of working. We could, of course, go to a completely agile model. And what we have in the agile model here is we're doing the design, try and build, and we're feeding back during the try build phase. So at least as we work, we're trying it out ourselves and testing it. And hopefully the API will be easier to understand because we've tested it and used it ourselves. Drunk around champagne is the expression sometimes used. But again, it's not necessarily the fastest, particularly when you're working within your own team to do the agile process. Which brings us to what's being referred to as API first, and this is a real game changer in terms of trying to get a good API. The idea now is that because it's a contract, we can work with potential consumers and design the API, and I can design what I think you need as the provider, and you can tell me whether that works for you or not during that early trialing, testing, using those API tools that we mentioned early on. And tools like Apiary and Dread, which Oracle provide, both being free, are tremendous tools for helping do that because you can design it and then you can give someone a test endpoint where they can try and call the API and it will pass back some dummy data, and they can develop their understanding, their experience of it, and how well it works with their needs. So you're getting all that feedback before any real code is being built, which is fantastic, because now the chances are that your API is going to be a good match for what's needed. But not only that, in the waterfall model, and to an extent the agile model, you have to wait as a consumer until the API is largely done before you can start building against it. Here, we can almost start and work in parallel. So as a project manager will get very excited by going, oh, right, okay, so I can shorten my project delivery timelines. I can get de-risk by getting more done and have some contingency at the end of the project. It really does make a huge difference. And it's something that it's very easily overlooked. But the classic one, if you're working in a large organization, is I, as the API developer, do not know who my consumers are. And that's not an unusual problem, but there are ways we can work around it, or at least reduce the impact of not being able to talk to the consumers. We can use test-driven development. Now that makes us the consumer before we are the providers, because we're writing our test cases against the APIs. We can take our API design and then benchmark test it and evaluate it by looking at best practices. Companies like Google and Facebook and quite a few other major cloud providers have got really rich, really good material explaining on what they view a good API as being. So you can look at their standards and say, how does my API design stand up against that? And you can then ask yourself, does that match? Is that good? And if you find yourself saying, well, actually that best bit of practice, that doesn't count in my case, you're probably in the place where you need to stop and really question yourself hard as to why are you trying to justify it not applying. If you're misusing verbs, then that's a real challenge, and you should actually be stepping back and reconsidering what you're doing and why you're doing it. Use a colleague as a substitute. And we can do this in a number of different ways. If you've got a business analyst involved in the project, they will understand your business domain that you're working in, and you can sit and talk them through the API design, and they'll be able to ask you very business-orientated, consumer-orientated questions. They may not necessarily have the technical understandings and all the nuances, but they are going to certainly get down to try the details of, does this API definition make sense? Does the language I use relate to the people that are likely to be using my API? Another option is to go to another developer that's not involved with your project. If they're not involved with your project, then they are not going to start assuming things about how your backend, or know things about your backend implementation. And therefore they're going to try and look at it as, how do I use this? And if there's anything in your implementation that's affecting the API design, it's likely to surface in those conversations, because they'll be asking, why is it that way? Because it doesn't necessarily make sense. If it's difficult to explain to someone outside the team, then consider how difficult it might be for someone that's relying on your API documentation. That could be, even harder, or will be even harder, because you won't be there necessarily to answer the questions about your API. And then if you're thinking about public APIs, then there's always the opportunity to go to social forums, chat rooms, Reddit or communityoracle.com, and just share your API and ask people to come back and tell you what they think. See if they understand your API without any explanation beyond you want some feedback. And they'll, people who are generally very good and generous with their observations and will more often than not be constructive in supporting you. Okay, so I've talked about the design. Why is the design so important? Well, this is a little bit old hat in some respects as a message, but APIs are becoming a very, very important part of the economy these days. And we as API designers need to get it right, because if an API is easy to adopt and easy to use, it's easier to sell what we're offering. If it's really difficult, then it's not going to sell very well. Imagine trying to drive a car that's really difficult, that it steers wrongly because the steering's at the back rather than at the front, that the accelerator is in the wrong place to where you used to, and so on. People designing cars like that are just not going to sell. A car where you get in, everything feels natural, it's where you expect it to be, and you drive it, people are going to adopt it or potentially be more likely to be a buyer. And that's why API designers are in many respects are becoming a new front line of business sales. And we've got the poster children of eBay and Expedia who actually make more revenue through their APIs than they do through their web interfaces, through their websites, which is quite fascinating. And there's a fantastic story around Walgreens, who were redeveloping or developing their print service where you could print your photos in a Walgreens store. And as part of that process, they just decided to dip their toe in the water, and they published that API. And the business really took off because suddenly lots of people were building into their mobile phone apps the use of this API. So now I could send my photos from my phone to be printed in the store. So when I walked in, they're all printed, ready and waiting well, and stood watching the printer as it printed out each picture. And they saw a jump in revenue. And then there's research here that shows from Cloud Elements, this is a slightly out-of-date report. There's a more recent report now, just came out a couple of months ago. But the numbers and the message are still reflecting the same thing, that 60% of businesses are seeing good API design as very important to their future and success. So it's really worth putting the time and energy into getting it right. So what forms a good API? Hopefully now that you've bought into the idea that it's worth actually taking the time and drilling down into getting it right. So some basic stuff. This is almost like a coding standards, if you like, for APIs, and using API to create API blueprints or an open API spec. Use your naming standards. In a URI, you normally talking about a single entity. If you've got the URI and then the entity identifier, use the singular name for it. It makes more sense, unless you're passing an array of values back, then in which case you can use the plural. It just makes sense. It tells people implicitly that they can expect one or lots of entities back if you're using the language clearly like that. Try and use really meaningful, correct language, and try and use language that's suitable to the technology domain or the business domain that you're working with. So, if an airline talks about a seat ticket as a voucher, then your API should be talking in terms of vouchers. If it's cars, then do we mean chassis, and so on. But try and avoid words that have a programmatic meaning, because you can introduce confusion there. And try and avoid overloading words. So don't use the same word to mean two different things. For example, if you want to talk about cache, as in the cache of something, that could get very confusing because we talk about cache with a very specific meaning within IT. And therefore, is my API relating to something that's happening with the technology, or is it about the business idea? Try and standardize the use of your names. So for many, many years, we've had coding standards that tell us how to use casing within languages, where the first letter is an uppercase, lowercase, and then we're using what's known as camel case, or using underscores to join words up. But whatever you choose, it needs to be consistent, because what you'll find is people trying to use or understand your API will pick up on that without having to read that that's how you've designed it. And then as they get more and more familiar with your API, they won't even have to look things up, because they'll know how you formed it. They'll understand the language that you're using. Agree when special characters can be used. Generally, I discourage using them because they can cause more confusion. They can upset some parsers. But if you're going to use them, make sure that everybody agrees that when they're going to be used and what they mean. This is true of JSON, but also XML schemas and other formats. Try and use the type system within the notation properly. It's very easy for people to create schemas that everything is a string. Even if the value is a number, it's still given a type of string. The problem is now you can't use the schema to help validate the payload. If you're not clear in the documentation, people might think, oh, that's I need to put the word to, not the number to, into that value, and then you get mistakes creeping in. People will try and hijack your fields because you've said you'll accept a string to do malicious things, unless you start type checking every bit of code manually. Think about your max and min lengths. This is important because fields can be used as a means to inject attacks. If you accept a really long string, people will try and shove some SQL in there to maliciously upset your back end. There are industry standards, ISO codes, and all sorts of other standards, RFQs, that are all really great for making your life easier to document. If you're going to use a date, why not use an industry standard date that everybody's going to understand? And then you can just say, I'm using date, and it's the ISO 3166, the 8601 format. Or I'm using country code as an alpha 2 character from the ISO 3166 to indicate language or country. Try not to nest structures unnecessarily, because that confuses people. People are going to look at structure to try and infer meaning. So if there's nesting a list of elements, but actually you only use one element, people are going to get confused. If values are nulled, perhaps we should consider making those values optional. Makes life easier, makes communication workloads a lot easier as well. And then we can get into the bigger stuff. Error responses, this is a classic one, particularly with old instances of IIS, where if it encountered a bug in the code, it would send an entire stack trace back. So you knew exactly how the website was built, whether it was running PHP or VB.NET, and had a SQL Server behind it. It's a great way to advertise for people to attack your site. By all means, say, yes, you've had an error, and use a response code so that they can look up guidance, and you can say, this is the way to solve and address this problem. but you're not telling people how you've implemented your back end. They can't then try and use that to work out how to make your API more effective, or use it in a way you weren't expecting. As a result, making things more brittle. So if you do change things behind the API, and they've managed to figure out how you're doing things, suddenly they may find their solution breaking. Utilize HTTP headers to the Phill. I mentioned that some of the challenges around cache control and why we should use it. Think about content type. Think about the consistency in whether you're using HateOS or not. But if people are asking for large data sets, define a way of dealing with pagination of those data sets and use it consistently across all your endpoints. Try and avoid complex parameters in your URI. Complex parameters can be used for multiple attacks in security. So it's worth trying to keep that nice and tidy. The top one says exactly the same as the bottom one. It's perhaps not as readable, but it's a lot safer because I can validate the value like eval to say, is it equals, greater than, less than. For example, I can validate that the variable is a meaningful name rather than a SQL word, for example, reserved word, for example. We can look at good API design from the Richardson maturity model. It's a little bit dated, but it's another perspective that we can use to consider how good and how mature we are. And perhaps the maturity model is due for a tweak because we've moved on. We've got some more innovative ideas beyond HateOS now with the arrival of things like GraphQL. So, useful to consider. One of the key ones for good API design, in fact, it's almost an essential these days, is the OWASP. That's the Open Web Application Security project. They set out every couple of years what they call their top 10, which are the most commonly occurring vulnerabilities. And here you go, you can see through 1 to 10. Number 1 is being SQL injection. Number 2 is broken authentication, with the fairly obvious things, but they are worth looking at. When I design my API, how is my API going to be authenticated, for example? And recently, in fact, I say recently, about 9 months ago now, OWASP published an API equivalent. Now, if I just flick back and forth, you can see that some of these are actually more or less the same. The order has just changed. So broken authentication is number 2 in both cases. For example, in the standard top 10, injection is number 1, but injection now appears as number 8. But a lot of the problems are still basically the same, so we can bring the same basic practices to a web page and web page security as we can to an API. And you can see, just addressing the data being exposed is we'll deal with number 3 and number 6 in terms of the amount of damage that too much data being escaped or being pushed back in can occur. If you're allowing lots and lots of data, it makes it easier to potentially create composite injection attacks. If we look at others, use security frameworks, broken authentication, broken object authorization, improper asset management. security misconfiguration. This is all about using good security frameworks and using really robust authentication authorization utilities rather than trying to homebrew your own. You know, there are companies out there like Okta and Oracle with its IDCS product who spent thousands of man years developing and hardening these things, and they still find mistakes in them and vulnerabilities that they have to fix. So if they put in that much effort in, what are the chances of you getting a home-brewed authentication framework right straight away and not being subject to lots of vulnerabilities? And then we've got rate limiting and overloading and just not being aware of what's going on with the payloads being sent. I mentioned the HTTP verbs. We all know about the get, post, put, delete, but a lot of APIs don't make full use of the response codes, and they don't make use of some of the others verbs like patch, which could be a better or an alternate way of representing an update. But typically we see people using 200 and maybe 400 as a response code, or maybe 404. But 201 is a really good response, and actually is more meaningful because you're going back and saying on a post, I've created this entity for you. Yeah. Or I can go back and put a 204 header, and therefore I don't have to return a message body at all, not even an empty one, because it says, this is successful, but I'm not passing the body back to you. The headers, we should be thinking about, I mentioned the caching ones, but there's some really powerful, nice ones that make defining the API a lot easier. Often we only want data that's changed in the source system since a particular date. And we end up designing into the API specification an attribute says date since or something like that. But actually there's an HTTP header called if unmodified since that we can use. Or if we can't put a particular entity into the URI because it's a bit sensitive to go into the path, we could use if match and put the key or the entity identifier in the if match value. Just as effective without needing to start designing payloads. And then think about, warnings that you could pass back. You can send messages back to say, yep, I've got your data, but it's not yet committed into the system, which is quite important, particularly as we move to more asynchronous APIs. Versioning is another classic challenge. It's one of those things that kind of gets thought about when people start saying, can you change this? Can you change that? And we go, oh, hang on, we've got other people using this that don't want that change. So it's always worth working out what your versioning strategy is and communicating it. Some organizations say we're only going to support this version and the previous version, and we'll only have breaking change a maximum once a year. So people understand the impact and how often they must be prepared to accommodate change. But if I'm versioning, how do I version? If I go back to Roy Fielding, he originally said, hey, you don't need to version. But the reality is that there are times where things do change and you're going to have to deal with a version. Things have to break. And therefore try and engage with it in a structured, constructive way rather than trying to retrospectively fix it in. It doesn't need to be difficult. It just needs to be an agreed way of working and following a consistent way of working. So let me show you a couple of strategies that commonly come up and some of the things that can trip you up or trip people up. You know, are we using semantic versioning or not? It's really easy just to say, yes, we're going to use semantic versioning. Everybody then knows 1.1.1 is a major minor patch representation. So the most classic is to put the version number in the path. Now, where you put it could have interesting meaning. You put it right at the start, so it's a subdomain. Does that mean everything in my subdomain is on version 1, and if I want to move it to move a version, I have to accommodate everything being on version 2? Or can I just change one entity within that? This one, okay, so I'm now suggesting that I can version specific entities, but do I have an entity called version 1? And then you've got that middle ground. So the pros and cons are, you can put it into the header. That's great, particularly for doing logic for routing. It means people haven't got to change the URI in their code to handle a new version. But the naming standard for your header attribute is not universal. Yeah. And moving on, the nearest thing to Roy Fielding and what he would have argued is the right way to do versioning is to use the accept header. But this is not my favorite because it gets fiddly, and the consumer's got to declare what version that they're going to accept. And you've got to be more aware of that and what happens if you're wrong and you can't support that. Non-breaking evolution, I'm not going to talk about this other than saying this is a tremendous approach. It's really worth looking at. It isn't as difficult or as scary as it might seem, but it solves a lot of problems because actually now you haven't got to deal with versioning particularly, and because you're going to be providing an interface in a manner that can always be consumed. Hate OS is a little bit of a love or hate thing, but it's useful to put it into the APIs because it gives indications of the operations that are available. And if you're connecting your operation to another entity or even an external surface, you can show how it relates to the entity that you've got. In this example, I'm just going to pull out one specific one. And if you look at the shipping cost, I've got a different URI. I'm actually passing a value from my entity and giving you a URI to say, okay, for this entity, you can now go find out how much it will cost to ship because I'm giving you the information in the URI. But it's more than payload descriptions. There's lots of... Hi.
Yeah, sorry for the interruption. We are reaching the top of the 45 minutes, so we can have a couple of minutes just to wrap up. Thank you.
Yep, I think there's one more slide after this. It's more, there's a couple more, but we will fly through very quickly. There is more than just the API definition. There is, the commercials. Do you want to put terms and conditions on using your API to absolve you of legal liabilities? Things like that. You might want to give a glossary of documentation or help. Yeah. And things like that, what form of OAuth are you using, and so on. Rate limiting, if you're putting rate limit on, people need to know that they can only call you so many times a minute or an hour, and things like that. What quality of service are you applying in terms of availability and things like that. So it's a lot more than it's a lot more than just the API definition. It's about making it readable and understandable. So I'm going to quickly whiz through this and skip forward. Sorry, I took a bit more time on the other bits, but I want to jump forward and just illustrate the point very quickly. I went to Google Maps and said, okay, I'm going to look at one of their APIs and see how that lines up with what I'm recommending as a practice, the practices that we take to our customers. Okay, and I mentioned very early on SDKs to make life easier. There they go. They're talking about they give SDKs. They're making it clear and talking about the audience and the expectation to be able to understand the interface. Yeah, they're giving you examples of the payload and the content. They're explaining about the pricing, the rate limiting, how they're applying security. And then if we look at this, look at the query. As you can see, the attributes are actually very small in terms of the parameters and very concise. And they tell you precisely how they are worked. You know, these are latitudes and longitudes, and this is how we represent a lat and a long. So it's very clear, very well understood in terms. And of course, there's the legal T's and C's about how often you can use the get out of jail, the liabilities, and so on. And that leads us with a minute or two to deal with a couple of questions.
Yes, we have one. I have two simple questions. Can you recommend us a standard to create our APIs? Can you share us the slides? This is from one of the attendees.
So standard, you can, you might want to develop your own, but I would always go to someone like Google that have had years of doing this. They've nutted out and learned all the lessons. So going there is always a good place. There are a number of good books out these days that talk about good API design. Manning have one, for example, particularly in the security space. If you're asking more about standards of Open API versus API Blueprint or Swagger, then I've always been a big fan of API Blueprint. But Open API is better understood by a bigger community. So it's about who you're talking to and whether they understand the API Blueprint approach or an Open API spec. I hope that helps.
Okay, thank you. And yeah, that's the question that we have. Let me check the other chat, and if we don't have any other questions, I think we can wrap up. Let me check. No, we don't have any other questions. Feel free to reach Phill via their social media in case you are seeing the recording of this session. And let me do the wrap up in Spanish. Gracias por habernos acompañado en esta sesión. Agradecemos su colaboración. Les recordamos que en laouc.org está la agenda de todas las sesiones. No dejen de revisarlas para que puedan registrarse a más. Thank you very much, Phill, for your time and for sharing with us in this online version of the event. Andres is saying thank you so much also on the chat. So with this, we are finishing this session. Thank you much.
Thanks very much. I wish everybody a good day and enjoy the rest of the conference.